Hi all, welcome to the 3alib demonstration of the functionality. My name is George Kouskiouris from NTUA and I will present the main concepts and functionalities of the abstracted availability auditor. We will begin the demonstration initially with some slides identifying the concepts and the rationale behind the library. So the purpose of such a library is to provide statistics for availability-based SLAs. The reason is to produce a benchmark and an auditor that will be able to dictate whether a specific SLA is kept or not. As an input, the library takes user credentials on a cloud platform. They are only stored locally. It takes as input which service types to monitor, for example AWS EC2, and an IP of the backend database for logging. The backend database is of a MongoDB type, which is schemaless, so there is no need for defining a schema or a specific structure. The output that is produced is availability statistics based on the specific provider's defined SLA and the identification of potential violations. Why this is important? It is because currently, to the best of our knowledge, there are no existing benchmarks that cover the metric of availability, but in terms of the specific provided definitions that are given in public cloud services, and this is the most important part. While approaches exist like Cloud Sleuth to measure availability in general, these are not adapted to the specific definitions that are included in the provider SLAs. Such statistics are important if we need to filter services or providers based on the observed statistics, and to check deployment plans if they are applicable for an SLA, because we will see that not all deployments are applicable, and to have a runtime monitoring to determine whether after a deployment the SLA is kept. So the motivation is that as it appears following an SLA analysis we have performed, it is not at all straightforward to measure a provider's and the services availability. Why this happens? Because in many cases SLAs contain a lot of legal terminology that hides a number of specific preconditions that need to apply in order for a specific deployment to be applicable for an SLA. So one of our purposes is to translate this legal wording to concrete technical terms. Also, to specifically mention that no monitoring or auditing information is given by the providers with regard to the SLA. They state very clearly that the user must provide these proofs of the violation. Another very important issue is that while the majority of cloud-based SLAs refers to availability, this does not follow the generic applicable definition, which is basically if you take a number of samples, some of them are unavailable, then availability is defined in general as the overall available samples divided by the overall samples including the unavailable ones. So the providers do not follow this logic, and also any availability measurement attempt must be based not at the application level but at the service level. Okay, so the final goal is to have these availability levels for a specific service, but by achieving also the non-repudiation requirement, which means that the provider cannot claim that we have measured the availability in a different way than the one they have defined it, or that there is some flaw in the measurement process. And the final goal is to have concentrated statistics for a specific provider. For example, that Amazon violates SLAs in 1% of the observed cases. For this purpose, we have built a 3alib or Abstracted Availability Auditor library. This is intended to be used as an availability SLA benchmark. In order to construct it, we have proceeded with the analysis of key aspects with regard to concepts that are included in SLAs. For these concepts, where possible, we have created conceptual abstractions, and these abstractions have been enforced at the code level in order to have a more efficient structure of the library. The purpose is to adapt the availability calculations that are done per case with a specific provider's definitions, and also to check the various preconditions of SLA applicability, and more importantly, to adapt also to the behavior of a cloud user or to faults that may occur during the measurement process, because it is very critical to have the non-repudiation requirement as mentioned. So in order to do this implementation, initially we observed the SLAs from three major providers: Amazon EC2, Google Compute, and Microsoft Azure. From these SLAs we have extracted the common concepts for which we have created abstracted methods, and the ones that refer to provider-specific terms have been encoded like provider-specific drivers in the 3alib implementation. Also in the backend, 3alib uses Apache JClouds that abstracts from the specifics of its provider's functionality and API form, and this is very helpful in order to abstract any implementation from the specific details. So the overall purpose is to give to a cloud user, one that has deployed their services on a public cloud, one abstracted and general method in order to observe the availability of their services, and another abstracted method in order to calculate this availability based only on the name of the provider and the service they are using. So this is a component diagram of a class diagram of the implementation. The blue cases are the abstracted methods, and there are some methods that cannot be abstracted. They are the specific drivers that are created for a specific provider and include the specific details that cannot be abstracted. The two main functionalities include the run availability auditing daemon, which is a daemon that runs continuously in order to gather samples, and the availability calculation, which is triggered by the user in order to measure the availability as is defined by the provider in the time interval defined by the user. So let's go to the concrete demonstration for today. We will see 3alib working against AWS EC2. Some SLA details for this specific service is that SLAs are applicable on the region level. We require to have at least two running nodes in the same region, but these must be in different availability zones as dictated by the Amazon SLA, and both of them need to be unreachable for the specific deployment to be considered as unavailable. If we have more nodes, then all of the nodes need to be unreachable for a specific sampling, for a specific sample in the process to be considered as unavailable. Also, in terms of compensation, Amazon gives out discounts in your Amazon account depending on the percentage of the violation, let's say. So 99.95% is guaranteed. Any smaller percentage has 10 or 30% discount depending on the size of the percentage. So initially we will have a cloud user. We will describe a bit the scenario and then we'll demonstrate how you can use 3alib. The cloud user initially has two virtual servers on Amazon Web Services, and they can inquire 3alib as to whether a specific SLA applies to this case. We will see that in this case it does not, because they are in the same availability zone. So as we saw in the Amazon details, we need to have at least two availability zones. So the user gets the feedback that they must deploy in a second availability zone also. So then we will proceed with a further step, which is deploying another server at another availability zone. We will inquire again the 3lib component, and we will see that currently we have an SLA. The specific instances can be regarded as applicable for an SLA. So also then the logging process starts, which includes pinging the VMs. We decided at this point to consider pinging as the way to identify the reachability of a specific VM. This is abstracted in the implementation, and if at some point someone needs to let's say replace the way this is determined, they can only change the specific method. So initially the setup of the services will be that two of the VMs are simulated as available, as reachable, and the third one will be configured as unreachable. It is configured through the different security rules that we have applied to the VMs. In the first two VMs, we enable ICMP traffic, which is necessary for pinging. In the third VM, we don't enable ICMP traffic, and that is why it appears as unreachable. So during this phase, the sample will be considered as available, because as we saw in the SLA definition, the entire range of deployed VMs needs to be simultaneously unreachable in order for the overall sample to be considered as unreachable. And then we will proceed with the change in the configuration, disallowing ICMP traffic in all VMs, which will conclude that the overall service is unavailable, and this specific sample will be logged in the database backend. Finally, we will run the method to calculate the SLA availability on the defined interval and based on the specific provider's definition. Okay, just as a extra slide, the specific calculation that is followed by most providers is that this is the generic availability that is not used in the case of providers. So typically the providers have this specific formula that they use for the calculation of the availability. So they accept that a specific downtime period is valid only if it is higher than a specific quantum of time, of a minimum, let's say, time interval, which varies depending on the provider. For Google it is 5 minutes, for Amazon and Azure it is 1 minute. So any unavailable sample needs to be continuously unavailable. Any type of service needs to be continuously unavailable for a time period larger than 1 minute in order to be for this to be a valid downtime period. So let's proceed with the demonstration. We see that we have two running VMs. They have enabled ICMP traffic, however they are in the same availability zone. So let's run 3alib in order to determine whether the specific deployment has an actual SLA. Initially, as I mentioned, we are using JClouds. JClouds helps us in abstracting the differences between the provider APIs. So we are getting the server list and their metadata details, which is necessary for our analysis in the following steps. I must first mention that in order for the tool to run, it's a simple jar file that can be run as a daemon. So I will launch it now as a daemon. We have disabled the daemon functionality in the Eclipse environment in order to check out the printouts. Also, a necessary outcome is the fact that it needs to have a properties file that needs to contain a certain amount of information. This includes the logging details in the provider, basically the IP key and the user key that are issued by a cloud provider for a specific user to make API calls. They need the IP of the database backend to log the samples and the according credentials in the database. And also you need to insert the provider name and the service name based on a specific template of namings that follows the JCloud's rationale, because it is directly forwarded to the Apache JCloud's library for contacting the respective provider. So now the call has finished. We can see that, as expected, we have 0 valid nodes that can be included in the specific SLA, because due to the way we have deployed the service, there is no valid nodes given due to the fact that they are deployed in the same availability zone. And you can check the feedback also. We have a failed check on the different availability zones. So let's now proceed to launching a third virtual machine that is in a different availability zone. You see that it is in US East 1B. I will start this VM. You may see that this is marked as no ICMP. This is because the security rules indicate that no ICMP traffic is enabled. Thus, in the pinging, it will appear as unreachable. Whereas in the other case, in the other two VMs, we can't see them at the moment since this cannot be unchecked. In the other two VMs that share the same security groups, the ICMP traffic is enabled, so in the pinging process it will appear as reachable. Okay, so now we have the daemon that's continuously running in the background. Let's see what happens in the specific case when we try to run the 3lib again. Now, what is important to notice is that in order to deal with this evolving user behavior, that the user may launch or stop virtual machines, and this action may make the specific service deployment applicable for an SLA or not, we must check in each case and in each new sample, we must check again the different preconditions that need to apply. So that is why the specific check happens again and again in each sample. So you can see now that in the specific case, because we have deployed in the second availability zone, we have found 3 valid node IDs that are applicable for an SLA. And what happens now is we are starting to ping each individual VM in order to determine whether it is reachable or not. If it is not reachable, and then this does not mean that the overall service is unavailable. All the VMs simultaneously need to be unavailable, unreachable, in order for the overall sample to be considered as unavailable. So let's check the printouts. You can see that due to the ICMP configuration, the first node appears as unreachable. You need to check also that we are, in each time that we are pinging a virtual machine, we are also pinging Google DNS. And this is why, this is due to the non-repudiation feature. We need to establish, we need to guarantee that our client from which we are measuring the availability has actually internet connection. So in order to demonstrate that, we also ping Google DNS in order to ensure that we have external connectivity and that this specific timeout is not due to a client lack of internet connectivity, but due to the other end, the virtual machine being unresponsive and unreachable. So the other virtual machines are accessible due to their configuration, due to the fact that there is no fault in Amazon at the moment, so the VMs appear as reachable. So the overall sample appears as reachable, and this is what is logged in the database. Let's go to the backend database and refresh to see what we have documented. You see now these are the one sample that we have gotten from the from running from inside the Eclipse environment, and the other samples are from the daemon that is constantly running. So this specific log entry has various metadata that refer to the specific cloud nodes, and in the end they have the overall determined sample that is considered as reachable due to the fact that at least one of the three VMs is reachable. So given that one of the three VMs at least is reachable, the overall sample is considered as reachable for the overall service. We will press again. We will see now we have 5 samples, and this process continues. Now if we want to simulate a fault in AWS, what we can do is to go to the specific security groups listing and disable all ICMP traffic. Okay, this means that now all the VMs will be unreachable, so the overall sample will be considered as unavailable. And we check the daemon here. We'll see that we get a timeout in the first. Google DNS is reachable, so we have connectivity at the client side. But the second VM also appears to be timing out. Let's check also from the Eclipse environment, but we should get the same answer. We check Google DNS again, it is reachable, and we check the third virtual machine, which again times out due to the fact that we have disabled ICMP traffic. This will show that all the VMs are unreachable, so the overall sample is unreachable. So you can see that the overall response is unreachable, and now if we go into the database and refresh, we will see that we have an unreachable sample. Now what is indicative in this specific point is that if we run now the availability calculation, it should produce 0, and this is because, as I have mentioned, we cannot just use the ratio of total sample minus the unavailable samples divided by the total samples, because the providers need to have at least a downtime period that is at least of 1 minute, and then by summing all the different downtime periods, then you can delete this from the total minutes of the month and divide this by the total minutes of the month to acquire the overall availability of the service. So check the printouts also from Eclipse. The single printout shows also that again in this particular case we have unavailable VMs, therefore the overall sample is unreachable. So we have another sample included here. And the third sample from the daemon. So now let's launch the availability calculation in order to check what happens for today. Now what will happen in the availability calculation is that we need to calculate the difference between this and this sample to calculate the overall unavailable interval and divide and subtract that from the overall time interval that we are interested in, and dividing that in the end by the overall interval. So now if we run the trigger availability calculation functionality. You see, it has the address of the database where the samples are included. It needs also the input of the time interval. Let's use November. And the 10th of November. And for stop year, 11th day. So now we get that the overall unavailable interval minutes is 1, okay, because this was the definition from the samples. Actually, it was 89 seconds. It was actually 89 seconds, but due to the fact that the availability definition quantumizes this in terms of minutes, the overall percentage of availability in the given interval we have inquired, the 1 day interval, is 99.96%. Now we must also stress that providers typically have a monthly cycle of SLAs, so when we investigate the overall availability, we must include the overall month. Even if we have not run the services for the entire month, the providers indicate that the entire monthly interval must be included in the availability calculation. If the service was not running in some part of the month or the majority of the month, if it is not running, it is considered as available. So this was the demonstration of the 3alib functionality. Currently we have developed drivers for AWS EC2. We are also completing the work for Google Compute and Microsoft Azure. These are almost finished, and we will extend to other services such as storage. Thank you very much for watching the demo.